Hey, y'all. I think my screen sharing, it looks like it's on, so we should be good to go. This is Kate. I know that a lot of you were struggling with Part C, so I'm going to do a quick recording of how I would CAD it. It's important for a couple of reasons. One, it's going to be part of your first exam, so it'll be at least, I believe, parametric equations, that is, will be 15 points of your first exam. But also it just gives you an idea of how I go about tackling a problem like this. So first I got to decide which plane I'm going to come from. And I've got my isometric view here that I can check out. And what I'm seeing basically is that if I come at it from the front view, so that looking right there, that's really where I've got the most complex geometry. And so I think it looks like a nice place to start. If I come at it from the top, I'm still going to have to do this whole thing in one piece. Yeah, so I don't think that makes sense. I'm definitely going to come at this from the front side. So I'd already selected my sketch tool. Now I'm going to make sure that it's highlighted, and I'm going to get going. So my very first line is going to be coincident with the origin, which is, we all know, because I won't stop talking about it in class, so important for making sure that you've got fully defined sketches. The next thing that I usually do is just get a rough shape. So I'm not going to go in and smart dimension anything until I have my basic shape put together. For this next part, there's a lot of ways you could accomplish these two circles. What I am going to do is draw two circles and make them tangent to the lines that I know that they'll be tangent to. So I'm going to do that by adding relations. So I'll click on my first line, then I'll click on my circle, holding control to select both, and then I can select tangent. So now these two pieces are tangent, but you can see pretty clearly that they're not connected. And since I don't have a fully dimensioned sketch, or this line especially is not fully dimensioned, I can just drag it over until it is coincident with the circle. So I'm going to do the same thing here. I have like grossly misjudged my proportions here. Let's see how we do with that. And then I know that I'm going to have a line that's tangent to both of these. And it'll often snap and help you, so I can see that I've got a tangent line for both of these. So now it's really time to just kind of clean this sketch up. So I'm going to go to Trim Entities. I often use the Trim to Closest tool, though you can play around with all of these. But it's going to help me get rid of those extra lines. And now I've got my complete shape. So now I'm on to my smart dimensioning. So now we'll make it look nice now. Ooh, and I have the wrong dimensions. This sucker is in inches, and look, I have it in millimeters. I'm a bad instructor. Let's fix that. All right, let's try this again. All right, so I already know I've misjudged a little bit here, so I'm going to drag this around so things don't go crazy when I dimension this to 2 inches. Yeah, like that. Oh, maybe I should talk for a second how I got this 2 inches. So I can see from the sketch that I'll go from this line, which is that, to the center of my circle, which is 2 inches. And so I'll create this dimension here because that's where my rectangle will be. We'll go in a minute. We'll go from the top view to create that arc and the hole that goes through the part. But for now, that's how you came to the 2 inch dimension. So this dimension will actually need to become a parametric equation. But for right this second, I'm going to leave it as it is. Okay, so we have a fully dimensioned part here. That looks really wrong. Oh. Yeah, okay. There, that was better. That looks nice. All right. So now I can go ahead and extrude. And I'm going to extrude it 3 inches. All right, so I've got my basic shape. Now I want to tackle this little arc that we've got going here. So I'm going to go to my sketch tool, and I'm going to select this plane. A Centerpoint Arc is probably what we'll do. See if I choose the right side. Yeah. So I'll make it start at the center of this line and then coincident with either edge, which should make it then fully defined. I'm also going to put in my hole, my circle now. There's no reason to wait. And that is one. All right, so my sketch is fully defined. I'm ready to go. So I'm going to start by extruding it. So I know that I need this piece. Flip its direction. That lip was 0.5 inches. Okay. I'm going to make sure that the sketch 2 is highlighted again. So I've done my drop down arrow, it's highlighted blue, and now I'm going to do an extruded cut. And I'll select both halves of that circle. And you could, I mean, you know the distance from there all the way to the bottom, but I'm just going to select through all, which will make it a through hole. So kind of the last piece, which you don't want to think about last, but we are going to talk about it last. So it's really important that I've put these 2 dimensions in the same sketch as this dimension. It's not impossible if you don't, but it's a lot easier. And so one of the things that I do, I know from the problem statement that I want both of these curves to change their size when I change the height of the part. And so one way to do that is parametric equation. And so I'm going to double click on the dimension to bring up the modify box, and all parametric equations will start with an equal sign. So equal sign, and then the ratio that I use is the number I want divided by my reference number multiplied by clicking on my reference number. So in this case, the number I want is 0.5. My reference number is 3, because that's the direct reference. The reference that I'm going to use, and then multiply and actually click on the dimension. Same thing for this arc. Start with my equal sign, the number I want, which is 1.25, divided by the number that's my reference number, multiplied, clicking on my actual reference. So now when I change this value, my curves are going to jump with it. And that is how I would tackle part C.